Okay, next is question number 13. Okay, the question says a high-speed train accelerates from rest along a straight horizontal track. Okay, part A. At first, the final speed of the train is 76 meters per second. Show that the useful work done to accelerate the train is about 2 𝗔𝗟𝗖. That means what? Gigajoule, right? So mass of train is what? 7.2 times 10 to the power 5 kg. Okay, so we need to find out the work done. So we know that the work done is what? The work done is basically the energy, the kinetic energy gained by the what? Train. So this is what work done. W equals to what? Half mv squared. So half times mass is how much? 7.2 times 10 to the power 5 times what? V squared, which is 76 squared. That much joule. Okay. So they said useful work done. Why we are considering kinetic energy here? Because the useful work done is basically the kinetic energy gained by the train, right? Okay, so that means half of 7.2 times 10 to the power 5 times 76 squared. That would give you, that's a huge value, 207,936,234. Okay, 4 zeros, that much joule. So we can write it like this: 2, then 1 2 3 4 5 6 7 8 9 zeros. 5 6 7 8 9, that much joule, which can be written as what? 2 times 10 to the power 9, right? 10 to the power 9 joule, because there are what? 9 zeros, right? So which can be written as, so 2 gigajoule. That's it. Done. Okay, next is part B. In part B, the question says the train accelerates for 180 seconds. The train has an input power of 16 megawatt. The input power is how much? 16 megawatt while accelerating. Determine the work done against air resistance as the train accelerates. So what's the work done against air resistance? Okay, so for finding work done against air resistance, we need to find out the total input energy. Okay, so to find the total input energy, we have they have given the total input power and the time is given. So from that we can find out the total input energy. Okay, so energy input, this is what? 16 megawatt. 16 times mega is what? 10 to the power 6, right? Times 180. Okay, so that would give you what? 16 times 10 to the power 6 times 180. Okay, so that gives, okay, that's a huge value, basically 1 2 3 4 5 6 7 8 9. Okay, so 2.88 times 10 to the power 9 joule. Okay, this is the total input energy. And so a resistance, work done against resistance, so energy transferred due to resistance, this is how much? This is equals to total energy input, that is 2.88. This is the total energy input, and from that we will subtract, what we will subtract? The total useful energy. The total useful energy is what? This much, the actual value, right? So that would be what? 207,936,1,2,3,4, that much joule. So work done against the resistance, let's calculate it out. So minus 207,936,1,2,3,0, 4 zeros. Okay, so that would give you 20064, then 4 zeros, 1 2 3 4, that much joule. So we can write it as 801 1 2 3 4 5 6, so 801 gigajoule. 801 times 10 to the power 6, so that means we can write it here as 800 801 times 10 to the power 6, that much joule, to 3 significant figures in standard form. Fine. So the total work done, it is what? 801 megajoule, or 801 times 10 to the power 6 joule. That's it. Okay. So that's all about question number 13 from May 2023 Physics Unit 1 paper. Fine.